All right, to organize quantitative data.
That's going to be in the recording.
Okay. So first, group observations into classes. Also known as bins or categories. Okay, next, treat classes as the distinct values of the observations. Oh, no, sorry, quantitative data. I just keep waiting for more like recorder sounds, like at any moment.
How do you have those?
Because it's not National Recorder Day. Have you not been looking at the walls?
There's signs everywhere, Kenzie. It's not National Recorder Day.
It's not National Recorder
Pete
Day.
has a whole bunch of recorders. Did he give them all away yet?
Oh, yeah.
He gave them all away? Oh, I asked him to save me one. What? Okay, hope so.
Someone stop it.
Okay, focus. Guys, we have to focus because there's very little time for these notes. Okay,
I'm sure we don't.
next, step 3. You construct frequency distributions, and there's not that much space, so I'm abbreviating. Frequency distributions and relative frequency distributions in the same way as with qualitative. Remember, that was our first step with qualitative data, was constructing the frequency table, and then we got the relative frequency column. All right, so there's 3 common sense guidelines for grouping quantitative data. First of all, the number of classes should be between 5 and 20. I'm not sure that you would have necessarily guessed between 5 and 20, but when we look at the couple of examples here, you can see that each one of these is a class. There are 7 classes in this first example, and each one of these is a class. There's 8 and 8 different classes in the second example. So you get the feel. You don't want 100 different classes because that's not really helpful to look at. The purpose of using frequency distributions is to help make our data a little bit more easy to look at and interpret. So, number 2, each observation must belong to exactly one class. Now that makes sense. That's pretty obvious. Remember, each one of these data points is an observation, so you wouldn't put one observation in multiple categories. That doesn't make sense. And then third, all classes should have the same width. So the 3 methods for grouping then. The first method for grouping is single value grouping. Single value grouping. I apologize, my line is too short. Single value grouping, and that's where each class represents a single possible value. It's the most simple grouping method that we have. So you can see here our number of TV sets in each of 50 randomly selected households, and then we've organized it into this nice frequency and relative frequency distribution, and each class is just one number. The second type is called limit grouping. In which each class consists of a range of values, right? So that's when we have too many distinct values to exist to employ single value grouping, right? You can see that my numbers range from 30 to 99. That breaks my rule, right? But to have between 5 and 20 classes. So you have some terms associated here with limit grouping. Speed round notes. Page 2. We have cut point grouping. Our third grouping method is called cut point grouping. Just like limit grouping, except for we're using this with data that includes decimals or our continuous quantitative data. Remember that term? So that kind of data we're using, you can see the ranges look a little bit different in our classes. 120 to under 140, and then 140 to under 160. So these are the types of phrases you would see in cut point grouping. And then again, you see some terms that we might see associated with cut point grouping. And now the fun part. 3 different ways to display quantitative data. The first being a histogram, which is just like our bar chart that we talked about on Friday with qualitative data, except for in a histogram we connect the bars. So we keep the bars connected. So that's a distinguishing factor. And when you're using Microsoft Excel, you actually have to be careful on which bar chart that you choose. There's only a few that actually have the bars connected. Now real quick, look down at these examples. You'll see these 2 forward slash marks. Those just indicate when your chart begins not where you would typically expect to see the 0. So the 0 value is not at the origin. You see that it's like shifted over to the right, and you're allowed to do that as long as you put those 2 slash marks there. Page 3, dot plots. Formerly my favorite graphing charting method until yesterday. A graph in which each observation is plotted as a dot on an appropriate place above a horizontal axis. So observations have equal value, that have equal values are just stacked up above, not on, above this horizontal axis. And it's really nice to use when you're trying to compare data sets and the shapes or the distributions of those data sets. Now our third type of diagram, now that's my favorite one now. The stem and leaf diagram. Also known as the stem plot. Developed in the 1960s. So here's this professor, John Turkey, at Princeton University, and he's like, there's got to be an easier way to display this data than these histograms and dot plots and frequency distribution. So he comes up with the stem and leaf diagram. So cool. Even in the book it says ingenious. That was a word, it was in the book. So it's easier to construct, right, than our frequency distributions or histograms, and generally displays more information, including both individual scores and intervals. That says individuals. Intervals. My goodness. It must be last period of the day. It's not useful with larger data sets. And it's awkward with data containing too many digits. Okay, so you can see in our examples here, we have 2-digit numbers. We've got a step-by-step set of instructions here. So as you tackle your Math Excel assignment this evening, 2.3, this is a good reference. But you list these all in order, and then you can choose either, you can see how in stem and leaf diagram A, each stem is just listed once, versus in B, each stem on the second page, each stem is listed twice. Right here. So you can see 19 and 19, 20 and 20, 21, 22 are listed twice. And that helps because sometimes you just have a lot of leaves and you don't want the leaves to be so long. So you can actually break the stems and list them multiple times. That's our notes for today.